Ratan Sharma, and I have been working in Mindfire since 2 years and mostly on .NET related technologies. So today I'll present you on basics of WCF and how security is implemented in WCF. So before we start, let me brief the agenda for the day. So we'll start from the how web service came into picture with all various small things that Microsoft proposed with time. That is the history of web services, and then the basics of web service, that the principle it follows, that is the service orientation. What is the architecture behind that? Then I'll introduce with the WCF basics, why we should use it, what are the benefits, and the architecture it follows. Then the few points that is important to understand WCF: endpoints and behaviors and bindings, how the contracts are defined. Then I'll show you a demo on how we can create a simple WCF service, host it, test it, and create a client which can consume this service with different endpoints. Then we will talk about the security aspect of WCF, how it is supported with different bindings actually. Then what are the security modes available in WCF that we can add into, and then the demo on security. So let's start. So the first thing is how initially the inter-process communication was happening. The main thing Microsoft at that time started is how they will run something on user's computer. Means Microsoft has launched their product and then they wanted some tools or some software application to run on user's computer. So the first thing they gave is COM, that is component object model. But the thing was, it is on single machine, single user. They give it to the user will deploy it and he can use the tool. So that was component object model. Then they came up with distributed component object model, DCOM, which was, the benefit was, across a network any user can access a component installed in any system. Then came the COM plus. The COM plus was actually almost the DCOM with the transaction in place. If let's say 5 different transaction is done and user want to roll back it, so the COM plus was available with that feature. Then came the .NET remoting. This is almost the proper way of web service at that time, where a client can call a service wherever it is hosted. But the problem was, it has to be Microsoft technologies. The client has to be a Microsoft client and the service has to be, obviously .NET remoting is Microsoft client and service only. So this is how inter-process communication was happening, and web service just then came into the picture, where the service is hosted in one single server and the client across various client can access that. So we don't need to give the component to any user and install it. It will be hosted in one system and all clients can use it. The client can send the request and server will obviously give the response. Then the problem happened at that time was, when one universal service we make, obviously all the clients should agree that how I will accept, means how I will talk with that client service. So two problems were there: a common data format and a common protocol to use. Let's say I'm going to talk with you, then I need to have a common language for talking, right? We need to create one common data format so that the service can also understand which data I'm giving, and what the service will give as response, the client should understand also. And then what are the rules I need to follow in the communication, that will be defined in a common protocol. So these two choices they had to make. So this web service guy and the client guys, they need to make one common thing. So the data format at that time they came up with was XML. So because XML was very basic and at that time that was in demand, so they came up with XML, and common protocol was SOAP, which is still now used. Then WCF. So basically WCF is a framework technology, you can say, which creates different service related application or any distributed application which is based on the principle of SOA, service oriented architecture. So what is service oriented architecture? These are actually known as 4 tenets of service orientation. which is followed in the service orientation. The first one is boundaries are explicit. So when services are talking to each other, they cannot go beyond the boundary. If a service is giving some information, then we just need to call it and consume it. We cannot do anything internal to the service. So that is one of the SOA principle. Then services are autonomous. The user or the client should not be aware of how the service is actually performing the job. Let's say the service is providing addition of 2 numbers. So we should not be bothered about how he's adding actually. Maybe he is using some algorithm to add 2 numbers. So that is autonomous on the service level. Then services share schema and contract, not class. So basically services, normally we share our class object and then we do some operation in .NET I'm talking. Then we get some response, but in services they do not share any class, any object. They'll simply share the schema contract, like this is add 2 number is the method, you give me 2 integer, I'll give you the response as integer. So this is my contract and I'm clear on this. So I will share the contract with you and the data I would receive from you and the data I will give to you. That is. Then service compatibility, this is almost the protocol thing again, that there are certain rules you need to maintain. Like if I am talking to you, if in HTTP mode I want to talk to you, then we have to settled in the HTTP mode. In some other policies, so the client has to be compatible with the service based on policy. Then why WCF? When ASMX service was there, and ASMX is very good to use, easy to create. So there are many benefits. The first thing is Microsoft had a lot of technologies, those are actually very useful, like the MSMQ we know. In bidding application, normally we can use MSMQ very effectively. Like I am bidding something, and if servers is paused at that time or is not able to process because of high traffic, so this MSMQ, what it does is you give requests, it will keep it in a queue, and when the service is again up and ready to process your request, it will get one by one and it will process. So this is a very good feature. There are a lot of feature from Microsoft only. So the WCF benefit was, let's say a Java client is there. Java clients want to use this MSMQ service in some of its application. So at that time there was no some service or some technology which can actually give this information that a Java client can use a MSMQ service or any Microsoft service. So WCF is one of that service which can act as a middle layer. Like we have created a service in WCF which is doing it all these Microsoft technologies, and then this WCF is enabled to all outer world, all technologies, all domains or all platforms you can say. So that is one of big advantage. Then multiple protocol support. In normal web service we can only use HTTP. Here multiple protocol support is there. Then the communication has been increased to full duplex. We can actually give a request, get a response, and again give back another request based on the previous response. So re-entrant type of call is there. Then different hosting environment. Previously only IIS was there for hosting. In WCF we can host a just self-hosted environment. Then WAS is there, Windows Activation Server. Then different serialization of option. Previously it was XML serializer, as we said. A common data format was XML. So client will give in XML and response will be in XML. But in WCF we can use serializer option so that the request and response will be serialized as per the user's need. Let's say I want to use JSON data, I will make it JSON serializer. Then this is the same thing. Message queuing can be applied to WCF. So these are the technologies which are actually combined together to create WCF. Like the ASMX web service, the old service, which was operable in the Microsoft technologies very well. Then it supports web service protocol standards, different protocol. Then the messaging oriented programming, then .NET remoting, as we said. Then enterprise services, attribute based programming. We can actually define a lot of attributes in WCF service. Let's say anything, primary key also we can apply. Then this is the brief architecture of WCF, where the application is at the top. Then it talks with the contract first. Like I want to work with this contract, this is the contract that the service is providing. Then the next layer is the runtime, how the runtime behaviors has been defined for the service. You know the contract, but you don't adhere to the service runtime behavior, then you cannot communicate with the service. You have to also be compatible with the behavior it is going to provide. Then what are the messaging channel it is providing, whether security is there or not, everything. Then the hosting environment, where the WCF service will be hosted, like WAS, or it will be a self-hosted COM object or Windows service, IIS, anything. So this is the architecture of WCF. And this is very important in WCF. Everything has to do with this, how you will actually reach a service in WCF. So basically what happens is, when WCF service, I'll show you that when WCF service is actually created, it will give you a WSDL definition. That is web service description language, or XML format data. What it does is, let's say I have created a service. I cannot go to each client and I will tell like, this is my service, this is the contract, these are how you can use it. I cannot say this. So any client who wants to use it can use this WSDL definition to extract how it is behaving, what are the contracts, what are the endpoints. So these are the things that WSDL definition will tell. And the important thing is endpoints, how the service will actually communicate with another client. So the client will have to need to know three things: address, binding, and contract. These are known as the ABC of WCF. So the address is self-explanatory, that the URI, where actually the WCF service is hosted. We need to know that, where exactly it is hosted, so we can point to that service. And the address also tells on the transport schema, like whether from the address you can see it is a net TCP binding or it's a HTTP address. So based on that only we know the transport schema, we know the security in that transport scheme, then the port it is using, then the path. These are the things. This is the address thing. Then the binding, actually WCF's all things are defined in the binding, like how the WCF service will behave, how you will communicate, what are the protocol it is going to use. So this is in the binding aspect, but they define it as already it is predefined. Set of bindings are there, you can use it for your purpose. There are custom binding also you can create of your own. You can name a binding and then customize it according to you. But mostly for our purpose, everything is ready-made. We just need to pick up one binding we need to use. And then contracts. Contracts, we know that the data contract is there, service contract is there, message contract. So service contract is the same, like add to number, integer, I'm passing 2 integers, and the return will be an integer. So this is a contract we need to work on. This is an operation contract. These are the operation. Then list of operation will combine and create a service contract. Like I give a service which is a lot of operation contract. These are the operation you can do with my service. Then the data contract is nothing but that XML piece of information that I'm going to share with the service. So whatever data, let's say I want to have a student check, I will give his ID and I will get his information. So I have created a contract which keeps like the roll number and the marks or class. These are 5-10 things I have kept in a contract, and this will be exchanged with me. Like I'm the client and the service is there, so this will be exchanged in between. So this is the data contract, and combination of these three, address, binding, and contract, will be the endpoint that we are going to define in the service. So what happens is, let's say I'm a service, somebody I have given one endpoint like this, but this client is not comfortable with dealing with this address or this binding. He doesn't support, he's an old one. Let's say I have used the net TCP binding, and Vijay is a service which has old like ASMX service he has. So how he will talk, then I need to provide another endpoint also for him. So at that time I will use basic HTTP binding, because basic HTTP binding provides the interoperability with the ASMX service. So he can use his endpoint, another person can use his endpoint. So these are like different doors to enter to the room. So WCF service is there. Then this is about endpoints. Any question on endpoint? Because this is very important. Then what are the instance, how the instance is managed in WCF service? There are 3 procedures. These are actually defined as the service behaviors. Like a service is there, and one of its behavior is instance management. So 3 types of instance management is there: per call, per session, singleton. Per call is, as you can see in the graph, like one client making different requests, and it is creating new instance. If you have set per call instance, then this is the approach it is going to happen. You make each request will create a new instance in the server. Then if you make it per session, then obviously one client one response, one client, one instance, one client, one instance. And singleton, that we will use it for our service right now, is like different clients making request will be in one instance. The server will only create one instance at one time. So these are different instance management we do in WCF through service behavior. Okay, so I'll quickly do a demo here. There are default templates provided by Visual Studio, so we don't need to do a lot of things. I'm creating a WCF service library here. Let me name it as eval service library. So you will see by default actually WCF provides you the service files and everything, so you can use that also, but we will try to develop it from scratch so that we'll understand it better. So let me delete these two files. So this is an empty project, WCF project. What we need to do is, first let's add a class over here. The first thing I'll do is we will define our data contract first, that XML piece of data contract. I have written this so that we can quickly add up. So this is like the class object I'm going to use, but in WCF you need to annotate with data contract attribute to use it as a data contract. So this uses a reference namespace, that is system runtime dot serialization. So if we add it, it's done. So inside this data contract, what are the members you're gonna use? So you need to annotate them with data member attribute. So we are going to use all. So this data contract is ready now. So this eval is an object or data contract which is having ID, submitter name, then comments, and the time of submission. These are the 4 fields we are adding. This is done. Now let's add another one. iEval service, and basically this is a class, but we will create an interface here. So this is an interface, and this will be our service contract. This is inside the service model system namespace. So this is our service contract, and inside this will be exposed to the all the clients. So we need to define some operations that we can do in this one. So these are 3 operations we need to do. So this is only submit eval, and all operation will need to be annotated with operation contract. So right now these 3, submit eval, get evals, and remove evals, these are the 3 operations we can do on this service contract, that is iEval service. This is your service contract is ready, then the data contract is ready. Now we need to implement this service contract. Like these are the definitions we have given. This is viewable to the end user or the client, but how we are implementing that we will do right now, which is one of the SOA principle, that user don't need to know this, how you are doing this. So we need to refer that iEval service here, and Visual Studio will implement this for us. These are the 3 different methods that we're going to use. This is simple C#, so I don't need to write it again. So these are the three methods, and the definition, like the global least eval I have done because we can actually test it in memory. So one global eval is created, and we are using that eval to submit that. We are creating an eval ID using GUID, new one, right? Then we will add that to the eval, and we are submitting that eval to the service. Then for get evals, we are simply returning that eval that is added to the service. Then for remove eval, we are simply removing it using the ID that is provided. So till now the service is ready for us. Okay, we can actually test, but since we have deleted the old files, so in the app config you will see there is a part for the service model. Okay, this much. All WCF related configuration is done in this system.service model only, and everything like 90% of work in WCF is with configuration only. The coding is as usual like C# only. You have created the data contract and service contract. So here we need to do everything. So there is a tool provided by Visual Studio only, edit WCF configuration. You can, using this tool, you can actually configure your service. So let me go to the service. So you'll see this is a service one, which actually we have changed this. So let me change this to our own eval service that we have created. Then there are two endpoints by default created. So let me change this to the iEval service that we are going to use. Then this is metadata exchange. Max HTTP binding is one of the binding that the client will use. That WSDL definition I'm telling, this max HTTP binding will actually provide that WSDL definition. So the client can actually read and understand it, what are the endpoints and what are the contracts available for it to use. So right now everything is done. Okay, we need to save it. Yes. So this is now changed. Let me build this. Okay, now we can test it directly using a tool in Visual Studio only, that is a WCF test client. And since our endpoint is basic HTTP binding, which is a SOAP endpoints, so we can actually use this service to test here. You see here, this is the binding that this is the endpoint we are providing, one endpoint, so we are having one UI only. So let us test it using submitting an eval, test data, then ID will be generated in the code using GUID, and the submitter, then the time is, let it be this one. Okay, I have submitted. Let's submit one more. Let's submit one more. Okay, now we can use the get eval method to get all those information we have actually added. Something is wrong. Okay, I got it. Actually we read that instance modes. So actually what is happening is, since I have not defined anything, it is creating each instance at one time. So we need to define that instance here. This is the service. Service behavior we need to define here. In the service model. So service behavior, we need to add the instance context mode equal to instance context mode single. So it will create a single instance for all calls. So right now we can actually test this service. Okay. Okay, let's get it. Okay, so we're getting these two values that is given to the service. Now let's say I need to remove one, so let me copy this thing, and the remove eval I need to pass this ID, and if I remove this, now again let's get this evals, we have only one eval, so the service is working fine. So this is a basic service for this. So let's say we want one endpoint we have exposed right now, we want some more endpoints to be available for this. So let's edit this, and how we can add some more endpoints to the services. Go here, add a new one, address let's say WS, and the binding I'm going to choose, let's say WS HTTP binding. Contract is IEval service contract. So this is done. Okay, now you will see two endpoints are available here. One is WS HTTP, one is basic HTTP, and they will do the same job, but according to the client they can use whatever endpoints they like. So this is like, okay, so this is like the basic how we can create a service and can host it and test it. So whatever you write it, you can actually test your service like this, but you need to remember that these data contracts are actually, all data contracts are not supported through this WCF test client. Let's say some data types are there which are dynamically generated, array list is there. So if I will provide here array list, the same thing will not be visible to the what we call that WCF test client. We have to, for testing that service, we need to create a client and do everything. So let me quickly create a client here to consume this one, and let's call a client will be a console application. Okay, so we have the client. For the client to execute, first we need to get this service address. So in the client we need to add the service reference where we have hosted the service. So this will search for the service. In here you can see the service is hosted. The service we are putting here, it will try to host that service first. So it is done and it found an eval service. So let's name it eval service reference, add it. It is added. Okay, and you'll see an app config is added with the values that were in the this what service app config. It is now added as a client endpoints. At that time those were service endpoints. Now the client actually got, these are the information which the client gets from the WSDL definition that the service will provide. So right now if it is hosted, we also can, I think, see this WSDL. I think so. I have not tried this. See, this is the WSDL definition. If you click on the service, this is a piece of XML that is generated, and this is provided to the client. Here you can see there are various things. That is, one is what policies are there, obviously the endpoint, the bindings. Then you will see the contracts also. Yes, submit eval, then get evals, and the parameter it needs, all are given through the what we call the WSDL definition. So now they are added into the client endpoints here in the client. So and we need to get the, let's say I want to check this with basic HTTP one. The name is basic HTTP binding underscore IEval service. So to consume this service, I need to write the code service endpoint, I think. Okay, let me get this to save the time. Okay, this is in the reference only. So what this line is doing is, we first created a client with the basic HTTP binding name over here. I think it's same. So we have created a client here with this basic HTTP endpoint. Then we are creating an eval. I've created 2 evals here and adding those evals here in the submit eval client function. Then we are retrieving those evals and displaying in the screen. So if this is a simple test client. So let me set up as a startup project. Okay, now if I run it, first it will ask me to press enter. Service is hosted here. Okay, we continue. Now these 2 evals are submitted here, these 2 evals, and finally we are retrieving those get 2 evals. This is client code data 1 2. Okay, so this is basically this one. We can also do like console what client is there, endpoint. We can also see the client endpoint name that we are using this. Each time this, since this is a self-hosted service, each time you have to host the service like this. So see, this is the basic HTTP binding we are using here. So this is like a simple, we have created a service, the contracts we have defined, and finally we have hosted it as a self-hosted service. Okay, now the WCF what's happened? WCF security. So the security aspect is very before that we need to first figure out what these 4 things means, because the WCF security is based on providing these 4 information to the client. That is the authentication, that when the client is, whether he is authenticated to use my service or not. If you want to provide that one, then you can use the authentication part. Then the authorization. I have created several service contract or operation contract, but I want this client to use only 5 operations, other client you want to use other 5 operations. So by that you can use authorization in that one. Then the confidentiality, how much that message is actually you are giving is actually confidential, so accordingly you will apply security to that message. Then the integrity, when you are transferring the message, is the data tampered anywhere or not, so the integrity of the data should be there. So these are the possible security mode given by WCF. Whether you want to apply no security, which is the basic HTTP binding we are using, that is the only binding that provides no security. You just put it, you can consume it from everywhere with whatever data possible, anyone can tamper that also. But you can customize that. If you want to use apply security on that binding also, you can customize that. Then the transport security and message security. Basically in WCF, the security provided to the whole thing is in 2 parts, transport and message. Let's say I'm giving you the information. There are 2 ways to provide the security to the information. Is either I will secure the information itself so that anyone get the information, he cannot decode it. That is one way to secure it, but at the cost of something. And then the transport is there. Let's say I am giving the service code data to Maninder, and if I will totally secure the channel that we are using, then obviously no one can tamper it. We two will go outside and will talk each other in private, then nobody can actually tamper that data. Otherwise I will send it in some information format, so no one can use it also. Then we can also apply both. but we don't use it actually both in our cases, but we can apply it. Then another one is transport with message credentials. You can means give some message credentials, so the transport is secured. Still, if someone gets it, then he have to give that credential. Then transport credentials only. These are the 5 different possible security mode. And this is a chart I got it from MSDN only, which actually shows you these are the different bindings, like the basic HTTP, WS HTTP, net TCP, net named pipes. These are different bindings, and whether they are supporting the transport mode, message mode, or mix mode. So this is a chart. Okay, you can see, you can refer how you want to actually customize your service. So basic HTTP, you can see this supports everything. So we can use it, but we need to customize it. And by default, basic HTTP does not support anything. So I'll show you in that demo of security that we can actually see the data coming and going in the basic HTTP. But when you will use the WS HTTP, which by default provides the message security, message level, so you will see the data is encrypted. Then you can see the net TCP binding, which provides the transport security, yet the message is not formatted and not secured. So these are different bindings. Okay, this is a graphical representation I've made for the same thing. Like this is a client. These are 5 cases we can think of. First is the channel is also not secured, message is also not secured. Anyone can see this. Good example of basic HTTP one. Then the client and the service, the channel is not secured, but the messages are encrypted. So this is a message encrypted, we can say message security. Then the third one is messages are as it is inside it, but the channel we cannot see. We cannot tamper in the channel, but the messages are not encoded. In the third one, it's a good example of the message security, fourth one, because you see there one client is there, it is consuming another service, that service is again calling to another service. Yet since you have already encrypted the message, so anyone who gets into the message in any point of time, he cannot decode it. So you see that the same data is again going to another service, but in an encrypted format. So only the receiver can decode it. So this is where actually message security should be implemented. Like I can think of this 4th point as a banking site, I think we can do, because it consists of different services. We do it from one page to another, but only the final person can actually decode that message. Then the last one is in the first phase the transport is secured, but the message is not secured. In the second, obviously if transport is not secured, we can see the message as it is. So this is another way. So these are different ways. We can actually create some more also, but this is how message looks like in a channel, if we provide service security or not. Then okay, I'll show you how the messages are done. In this demo only, let me show you in the first part. So these are 2 endpoints. Let me first use basic HTTP, and I'm submitting here test basic HTTP binding. Okay, I invoke this. This is actually saving it. So if I'll see the path, how it actually took the response here. So you see the request you are sending is not at all encrypted. You can see the data here. Test basic HTTP binding. The code data is over here, and the second submitter name is there. Everything the user can see. If you do the get eval for this, same thing. In the response, you can see the comment, the ID, the submitter, everything is visible to the user. So basic HTTP doesn't provide anything here. In the WS HTTP, it provides by default the message security. binding. Submit. Okay, now invoke it. Okay, in the XML you see the request, since the user is sending, we can see, but the response, if you'll see, here is the data, it's in an encrypted format. So anyone tampers into the data also somewhere, the message security is by default given to the WCF. So if you are using some latest framework, or you don't need to give any backward compatibility right now for your project, then you can go ahead with web security or WS security, because they contain by default message security. You don't need to apply anything also. This is a good example. Okay, here you see two datas are there. This is also encrypted. So okay, this one HTTP binding data, that's why I can see that one. Okay, let me show you one more transport one. I can add one more endpoint here, net TCP endpoint, so we can see how transport level is working. In the endpoints also you will see host is there. This host is a base address we have given. When you apply multiple address endpoints, you need to provide a base address. So that base address will be picked up, and the endpoint name or address that you are providing, that will be appended to that. So we can edit it also. Okay, I edited it, and let me create one more service endpoint, TCP, net TCP, and the binding we will choose is net TCP binding. So this is the contract I've given. The net TCP address will be somewhat different. Local host, let's say giving 9756. Okay, so another endpoint is added here, net TCP, and if I choose this one, okay, in the address that I provided, I forgot to give a dot here. Okay, this is because net TCP we have to use a different port than the normal one. So if I now run this, I think it should show the yes. See, here now 3 endpoints are there. The TCP endpoint is here. So if I add some value here, okay, data is here. You'll see this provides the data, but internally the transport layer is secured. The message is not secured, but the transport layer is secured. So this is actually basics of security I could think of to give here. But anyway, we can actually implement a lot of security. Like the basic HTTP, we can provide both the security, message also and transport also. And then the authentication part, there is one keyword in this one, client credential type. You just need to put the client credential type, and then you can apply that authentication. Then certificates are there. You can create SSL certificates. There are various free tools also available for local host testing. So you can create certificate for your website, you put it there. So as HTTPS security you can create on that one. And for the transport one, the same thing, none, different type of mode we can set up. So I think I'm done. Anyone, any doubt? Any questions? No. Okay, these are the few references. Actually, the whole Google is my reference.
Thank you.
Thank you.